Okay, we are on 12.4 today, which is page 967 in your textbook. And today we're doing an extension, or actually the exact opposite of what we did in class last period. Last period we were solving exponential equations. This time we're solving logarithmic equations. So keep in mind one more time, if you were to have, let's say something like 5 to the x power equals 125. In order to solve for this, we would rewrite it in log form, which hopefully this is really simple by now to do. And we would go find this answer on the calculator by doing log base. Math up is our log base, 5 of 125, and that gives us that 3 is the value for x. We should always go back and check our answer here. Since 3 is x, 5 to the third power, okay, that makes 125, so we're okay. So that's an example of solving an exponential by writing it as logarithmic. Today what we'll do is take something like this and go backwards, and we kind of been doing this stuff already. So most of this should be pretty straightforward. So if you flip over to page 968, what we're first going to do is look to sketch a graph of this function right here. And we don't use this whole, this natural log a lot, but it is something that we can use. It's just another type of logarithm. Remember that natural log is always base e. You don't have to write that in there unless you're solving it. We can just type in ln on the calculator. So what I would first do is type that into your y equals. Let's see if we can see that a little better. 55.4 plus 2.73, and that says ln. ln is next to the number 4, natural log, and instead of t we'll type x, close our parentheses. And when we graph this, sometimes the graph doesn't always show up, and in this case it's done graphing and there's nothing there to graph. So if you hit zoom and find where it says zoom fit, which is number 0, zoom fit will always give us the best fitting graph, and it looks something like this. If you look at your table, you can kind of tell that these are all errors, which means we don't have any answers, and we start our graph at 1, 55.4. Okay, so here's our graph. We're going to kind of sketch this. I'm just going to copy it exactly like we're looking. It's going to be something like this. That's good enough. But maybe if we had some table values, 1, 55.4, 2, 57. I'll call it 3, etc. Okay. And if you look at this, we can now answer some questions. The domain of this function. Well, if you look at your table, less than or even not even equal to 0. It'll be from 1 forever. So we can say the domain is all the x's that are bigger than 1. We could probably say it's even equal to 1. Okay, another way to write this would be bracket 1 to infinity. The bracket means it includes that number. Obviously, we can never touch infinity. The range in this case, well, the range is always going to go up and down. Remember, it's logarithmic, so we can go down. This is all real numbers. Okay, and these are all just asking about the problem situation. And in this problem, we're just talking about time. So in reality, you can't have a all real number range in reality, so the smallest range we can have in the problem is whatever the smallest k value is, which is 55.4. So in this case, the domain can still be that, but the range would be from 55.4 all the way to infinity. Okay. All right, so I'm going to come down here to number 2, and this is really when you're going to start seeing some problems. Okay, so we have this equation, and it looks really weird. 10 times log of I divided by I naught. Anytime you see a little sub-zero, that means I naught. And we're going to tell us some things about this. They say that I naught is the intensity level of the threshold sound, and quantity I is the number of times more intense. And obviously dB is the decibels. Okay, so when they measure sound, that is called a decibel measurement, and this is the equation for finding that. What we're going to do is we're going to kind of type in some things here. It says the sound in a quiet library is 1,000 times as intense as the threshold. In other words, they're saying I is the same answer as 1,000 I naughts. So how could we rewrite this? This looks really weird, and it sounds kind of like a foreign language. But all we're going to do is we're going to say that I is that number. And we can actually use the calculator at this point and solve this. The nice thing is I naught, when you divide it by I naught, they have to cancel, and think about it. 5 divided by 5 is 1, which means x divided by x is 1, which means I naught divided by I naught is 1. It cancels. So really all we care about is this. And that's how we find the decibel level. So let's go to our calculator here, and let's type that in exactly as we see it. 10 log, we don't have to do log base, because the base is automatically 10, and that's already the same base. Type in 1,000, we get 30. So that means the decibel level here would be 30 decibels. The sound of traffic on a street calculated is to be 500 million times as intense as the threshold. 500 million times. Holy cow. Alright, so what we're going to try to do is figure this out. So again, we're going to use our equation. Now this is the million times. It looks like the quantity I is the number of times. So this tells us that I equals 500 million I naughts. Same idea as up here, we're just typing it in slightly different. Alright, so we're going to write 10 log 500 million I naught divided by I naught. And these will cancel again, so all we care about is this equation. So let's type that exactly into our calculator. 10 log 500 million. Decibel level would be 86.9, almost 87 decibels. Okay. On the back, they did it the opposite way. The sound of a crying baby is 115 decibels. How many more times intense is this than the threshold? So now we're working backwards. Remember, this is our equation. So now what we're doing is we're going to kind of plug this one in for our decibels. And this time what will we do? Well, we'll have to work kind of this. We did this a little bit yesterday. We got to work backwards here. The first thing we got to do is divide by 10. And now what we should do is we should rewrite this as an exponential equation and think, what is the log base if there's not there? And hopefully you remember, it's 10. So when we rewrite this now as an exponential equation, because I can't solve it like it is, we're going to move the 11.5 to the other side, and now we can trace our e. So this says 10 to the 11.5 power will be this value, which remember this is the intensity value, which we actually care about because the intensity is measured in I naughts multiple times. So all we really care about is this value. Okay, I hope that still works. I have no idea. Hello, fire drill there, which you probably heard if you were in class, so you would know about when we're doing this. But we are stuck at this part right here. We did 10 to the 11.5 power equals our answer because that's the rule for exponents. So 10 to the 11.5 value gives us 3.16. That would become our value. Okay. All right. All of that is really important, but there are three situations where you will solve. The first is if, in log form, x is in your parentheses. This is real quick to solve. All you do is your E shape. So to solve this, it would be 5 to the 3.1 power equals x, and now we can solve that immediately on the calculator. 146.8. Okay? You don't have to worry about change of bases because the calculator will do that automatically. Okay? Over here, another way that we might solve an equation in log form is if x is our answer over here. And this is the best one because all we have to do is type that into the calculator. So we're going to go math up, log base. We're going to type in the base of 8 and 145 in the parentheses, and we get 2.39 for x. So on a test, we want to see this. And then we want to see this one because it's real quick. The last one is if x is our base. And in this case, you're going to have to do two steps. The first thing you do is rewrite it as an exponent. And remember now, if whenever you have a base that you don't know, but an exponent that you do know, the trick is you make the exponent a fraction and you flip that exponent and you do it on the other side, because this will cancel that out. This is going to be 24 to the 1 over 6.7 power. 24 to the fraction 1 over 6.7 power, and we get 1.6. So you're going to have three types of questions. You're going to have a question where x is in the parentheses. You're going to have a question where x is the answer. Or you're going to have a question where x in log form is the base. And those are all the things that we have to do in order to solve these. Okay? We're going to skip over now to number 9, which is page 973. And it's very important that you follow along, because in order to get your homework today, you're going to have to be showing the sub all of these problems. We're going to work a couple of them, then you are responsible for the other ones with the sub and check them. Okay? So the first one we're going to do is look at A. I'm going to do one of each problem. Okay, log 4 of x plus 3 equals 1/2. We should actually already know how to solve that. Since it's log base 4, we can do our e, and we can rewrite it as 4 to the 1/2 power equals x plus 3. We can go to the calculator and solve. So 4 to the 1/2 power is 2. It's 3. And to solve for x, we subtract 3 to the other side, so x must be -1. First problem done. Second problem, we have x over here on the right. We're going to again do our e. Okay, and the only time you can ever do e is when the log and the base and the number, this is all isolated by itself over here on the left side. So our e says 4.5 to the x minus 1 power equals 9. And if you do this, we've actually made the problem more complicated, because now I can't solve for an unknown x unless I go back to log form. So this is not the best way to do it. I would just say, let's type that directly into the calculator. What is log 4.5 of 9? So we're going to go math, up, log base. Let's type in 4.5 of 9, and we get that 1.46 is that answer. So we're going to set it equal to x minus 1, because that is 1.46 equals x minus 1. And we add 1 to both sides, so plus 1. So x is 2.46. And the last one is, what if x is our base? Well, in this case, we can't just solve this yet on our calculator, so we're going to do our e to change to exponential, which means x plus 2 is a power. Put it in parentheses if you have a whole bunch of stuff. Third power equals 7.1. Now this is where a base we don't know, but we do know the power. So make the power a fraction, and to eliminate the power, we reciprocal the power. So this becomes x plus 2 equals whatever all of this answer 7.1 to the 1/3 power is. We're going to write 7.1, raise it to the power of 1/3, and we get 1.9. We have to subtract 2. So x is negative 0.07. Remember, you can always check these answers. If you check them, you're going to do store alpha A, enter. That now stores it, and you should always come back up and check your answer. So we're going to go log base, math, up, log base. And this says x plus 2, but I stored it as alpha A. So I'm going to add 2, and I'm going to do 7.1 in parentheses. When I hit enter, I should get 3. Okay, so that becomes the correct answer, and I've now checked it. So what your obligation is to do is to complete with your table D, E, F, G, and H, and check those with the sub. Keep in mind that on part E, if it's natural log, your base is E, so use E. And on H, if it's log, your base is 10, and only 10. Work those problems. By now, you should have come to number 10, once you're done with working those problems. And these are now quadratic equations, and these ones are a little bit trickier. Alright, but in this case, we're still going to follow the same operation. We know the log of 2, we know 4, we don't know the argument in parentheses, so we're going to do our e, which makes 2 to the 4th is x squared minus 6x's. We can solve 2 to the 4th on our calculator, and we get 16. And over here now, what we do, this is now a quadratic, which means we need to use a box. But we have to first move 16. We can't use the box unless we get it equal to 0. So our box has to be everything here inside the box, x squared and minus 16. So we have xx on the sides. We want two numbers that make 16 that combine to be 6. So that becomes a minus 8 and a positive 2. 2x minus 8x makes minus 6x. Now our answers are on the sides. That means 0 is x minus 8 in parentheses and x plus 2 in parentheses. So the answers for x is always whichever one of these equals 0. Positive 8, negative 2. There's our two. Alright, last one we're going to do down here. By the way, try B with your table now. Same idea. You'll try that and show that to the sub as well. Last couple ones we're going to do right here. Here's a crazy big equation, and they're going to tell us all the different things. It says C is the current amount of medicine. A is the original dose of medicine. We're going to divide those using logs. And R is the rate. So that's going to be a percentage that it leaves the body. So let's see how we can figure this out. A patient is given 10 milligrams of medicine. Well, if he's given that, that's the original dose. So this is an A number. It leaves the body at a rate of 20%. So that's an R number. How long will it take for 2 milligrams to remain? That's a C number because that's the current. We're going to plug all these in and solve for T. So let's see. T equals, well, log is just log. C is 2. A is 10. Divided by log again. 1 minus our rate is 20. And you have to change that into a decimal. Remember, you always do 20% turns into 20 over 100, which is 0.2. And this now is a 100% calculator. Let's go to the calculator. We're going to make a fraction. Log button. Don't have to do log base because it's already just log. Fraction, 2 over 10. On the bottom, log again, 1 minus 0.2. And there's our answer. It'll take about 7.2 hours. On the back, 6 hours after administering 20 milligrams. Well, this is in an A value because you're administering it. 6 hours is your T value. 5 milligrams, that's a C value. What's the rate? We are now solving for R. So remember the equation? I'm just copying it from the front. It said log C over A, log 1 minus R. We're going to rewrite everything that we can write in. Well, T is 6, so put a 6 on the left. Log C divided by A. C is 5, A is 20. Log, we're going to write 1 minus R over here. We're going to figure out what this rate is. Alright, so we got to work backwards, and this becomes really tricky looking, but it's really not that big of a deal if you just break it up into pieces. Okay? Over here we are dividing two things. Since R is right there and I can't type any of this into the calculator, I can type that in the calculator, but I can't type this. What we're going to do is we're just going to undo the opposite, or write what the difference is. What's the inverse of dividing? Because we want to bring it to the other side. Well, to do that, we multiply. So let's just write it what it looks like. It looks like 6 is on the left already, and we're going to multiply it, so put a dot, by everything on the bottom. Don't overthink it. Just copy. And now we get this. Alright, well, we can find this on the calculator. So let's see. If we come to our calculator, clear it out, we're going to do log base, because we have a different base, 5 and 20. That gives us 1.86. So this equation is really 6 times log 1 minus R equals 1.86. Well, now let's start working it backwards. How do we get rid of 6 to the other side? Divide. So now we get log 1 minus R equals 1.86, which we have. We're going to divide that by 6, and now we get 0.31. And we're almost done. The problem is now we can't really do much with this problem because we can't type log 1 minus R in the calculator unless we remember that's base 10. And now we can rewrite it as an exponent. So we're going to do our E for exponent. 10 to the 0.31 power is 1 minus R. And now we're almost done. So we're just going to go 10 to this power. I'm just going to go grab it real quick. 10 to the power of 0.31. And that's going to equal 2.04. And now we're just going to solve for R. Let's see, since R is negative, I'm going to bring R to the left and make it positive. So I'm going to add R, and then I'll have to bring the 2.4 to the other side. Let's see, I'm going to write it down here. I'm kind of losing space, so let's write it over here. We're going to say 2.04 equals 1 minus R. I'm going to add R to both sides. So that way my R is gone. And then I'll subtract 2.04. So R is going to be 1 minus that 2.04 number, which is our last answer, And I get 1.04, negative 1.04 as my number. And there's your value. Okay? And that would be your rate. I want you to try number 3 with your table. And when you're done, you should be able to check number 3. And I will have all the answer keys up there. Okay? You should be able to check letter B on the page before. This is page 974. And then you should also be able to check D, E, F, G, and H. And once you get all of those, you may get the homework sheet that goes with this and have this turned in before the class period is over. You have plenty of time. Enjoy your weekend. You have a 3-day weekend, and I will see you guys on Wednesday.